This guy just burned out, so the conveyors aren't running. But I'll put some of these in manually. This is a sorting setup, very nice. Put some of these in here. As you can see, that subsystem reloads another cart while it's waiting for the laser. And then the laser does a very slow rotational move. I'm trying not to get the laser reflection in my camera. It'll burn out the CMOS, but actually, I have this in my hand. I'll be able to just do this. What I'd like to do is basically start the laser now before it's even in there, and then it'll start lasing. You know, it'll start doing the movement, the rotational homing movement beforehand, and then the gripper operates independently of the laser stuff, so that'll speed it up quite a bit. And then if I'm able to do a timer on how long these take, I could possibly have it grab it now kind of thing, like not even wait for the second one, the second rotational movement. It's just a shame how slow that motor is, and it's out of my control unless we want to buy a $1,000 motor from Laser Star, because they just hard-coded a really slow rotational limit on their freaking motor for some reason. Put some more of these in here and I'll show you. The idea is you put a bunch in here, the conveyor brings it down here. These guys kind of springy move out of the way in an attempt to singulate everything. And then they come down here. Just make sure that only one goes down the chute at a time. Just like that. And then these capacitive sensors know when this little chute's full. Start that. These little electromagnetic solenoids go until there's one in the chamber. This camera is attached to this Raspberry Pi image recognition system, coded up by my partner in crime, Jimmy. Oh, looks like we had a bad thing happen. It's actually a good chance to show you this. Not really sure why I did that. I'll have to review it. Still in this process of debugging, sometimes a weird thing will happen like that, is because some set of variables work themselves into condition of just doing a random weird bad thing at some point. And it's really annoying. You just got to watch it run for long periods of time, and then when something bad happens, you stop it, try and look at what's going on. Why did it do that? Was it a software thing or a hardware thing? Try and recreate it, then try and address it, and then test it again and see if it happens again. So it's been a whole thing. Here's the inside of the cabinet. This is a camera that's networked. This camera I've also set up and networked. Just plug it in like that before I leave usually. And then I have a third tripod mounted, what's it called? Turret camera that I can move around, and I set up right here so I can work on this remotely. And what else? I guess the last interesting thing is how this elevator works. It has this is a 3D printed chain. And these are TPU 3D printed brushes, like kind of bristle things. And they basically go into the track. This track is extremely picky and really, really well sized for these so that they have almost no wiggle room. Then it goes into there, and then a brush gets behind it and then pushes it up. Let me see if I can turn on the relay elevator. So it may be that the reason this got stuck is because this particular cart is a little chonky or something. And it messed up the Raspberry Pi for a similar reason. It goes over the top, falls in, goes through that hole. Boop. And then this sensor knows when there's so many. And then these solenoids do the same thing where it drops one out of sort of a area between the two solenoids. So the bottom one goes first, and then it empties it, and then the top one opens up and closes again, and then pinches the one above it. So now we have one ready to go. And then it drops it down into there. These guys are pneumatic grippers. They just go ch-ch with the help of these pneumatic solenoids. So those just provide, pressure or no pressure on or different sort of air signals that go into here. If air comes into here, it forces it open. If air comes into here, it forces it closed. And there you go. This is a sort of, I guess, 1 degree of freedom, 2 degree of freedom arm, and then the gripper at the end. This is a plate that allows it to go back and home. This is a proximity sensor. All of these are super custom 3D designed, like plates and gear train systems and stuff. This thing, when it's homing, it goes back, pushed against this. This is a spring plunger, and then this plate runs over a limit switch, and then it homes. And then this is just to kind of push it back. I don't even 100% remember why the spring plunger was necessary, but it was for some reason to kind of push it back off home. So that it always fell forward when unpowered and not into if it lost power while it was up, it didn't fall back into the limit switch, I think. And then it would turn on and the limit switch would already be on and homing would explode and die. And yeah, this goes forward and backward. This is another pneumatic grip thing that goes. And here's the vacuum that pulls the smoke out through there, and then through there, through that hose into this air processor. No, that's the compressor. This is the air processor. The elevator is really annoying me. Let's turn that off. And then this is the big, bad, scary thing. This is the laser. This is a Laser Star Fiber Cube. very overkill for this application, but we didn't know what we would need when we started, so we figured it couldn't hurt. The entire gantry can go up and down. There's a linear motion rig with what's it called? Threaded rod, Acme threaded rod, and the dealio. Yeah. There's a control box, e-stop, bang, press that, everything stops, run, idle. Here's a purge mode, which does everything the same except for when it takes this cart, when this takes this cart out, it pulls it out and then just dumps it right into here. So if you actually didn't want to process, laser engrave a batch of these guys, or there's some left over after your last batch, you purge it and it gets everything out of the system, because these carts are pretty much trapped in the chutes. You'd have a hard time getting them out. There's a brim on this that keeps them in, It looks like they're easily accessible, but they're really not. And so, yeah, it's a good way to empty out the system, very easy. And then there's a selector here, small and 0.5 gram, 1 gram. Here are the half grams. Different length of cartridge. And so that was one of the biggest obstacles in designing this whole thing, to accommodate both of those. These tracks, the radius of curves is really important. You can never have a front to back cartridge of either length in chutes when they have this fluted end, because they will wedge against each other. You'll have two of these guys like wedge into a corner, kind of like that. They'll just get jammed into it. And that really mostly happens around curves, because curves you have to open up a little bit. The radius has to increase as you go around the curve, like that. Because it's a straight line and it needs to go around, so you need to expand the curve, and then they jam. So that's why we put this sorting system right off of the output of the conveyor, so that all of this curvy stuff, they all are aligned ideally. And I think that's just about everything. All of this whole PLC cabinet, custom, just kind of had to learn how to do this and figure it out in real time. This is a Productivity 3000 from Automation Direct. This is the PLC, the computer thing. Each one of these is a different module that lets us do different stuff. Here is an input, a digital input, an analog input, a relay output, which is a sourcing output. So these are kind of similar. And then here's a module that gives me switches and buttons, so I can do, stuff. I can assign them to stuff in the program and allow an operator to do some stuff without having to know how to work the software. And yeah, it looks like kind of a mess. Honestly, this was after me doing a lot of cable management. Cable management in PLC cabinets turns out to be really hard. I don't know. When you see a clean PLC cabinet like this that looks tidy, and this isn't tidy, if you see an actually tidy one, it is an extremely impressive feat, and I respect 10,000 times more than I ever would have if I hadn't done this. Here we have a door safety sensor. These are magnetic sort of closer things that I made up, so that this has some holding closed power. Here are some like flexible baffles, so that laser light can't leak out through the gap, which is important because this stuff stays, this laser light is infrared, and you may not even be able to see it, but when it bounces off of metal through a gap into your eye as you walk by, it still remains, collimated or coherent, and it can damage your retinas even if you are getting a stray reflection off of something as you walk by through a crack. It's pretty scary. Here is a Hall effect sensor mounted. You will notice that basically everything in this guy is 3D printed and custom. I've designed hundreds of parts for this. All these gears, everything, every link of chain, which are all held together by M3 screws. Everything is 3D printed and custom designed by me. There's a little spring in this that springs it back into position. Everything. The only thing that I didn't design was the conveyor. And I'm just running it out through an AC relay, which may be a bad idea, apparently, since that just burned out. I'm going to have to reach out to the manufacturer or look inside this and see if there's a DC relay input. Other than that, this is all 2020 extrusion. The chutes are kind of designed to be modular-ish, and they screw together and they're self-centering, and where they meet, I designed it so that there's never a positive lip. They're always going off a little ledge, and that's in both directions, so that you never have little lips that carts can jam on when they go through all this. Everything is so insanely intricately thought out. These are all modular. They can be rotated. This is called a hearth joint, so they're in increments of, I believe, 5 degrees. I can't remember, maybe 10 degrees. And you take this off, this top piece off. There's a set screw in there. You open it up, and then you can rotate this and adjust it. These, can just be pulled in and pushed out to set the length of them, so that this allowed me to have like a modular test bed, so I could find and try stuff that worked at singulating these cartridges that get knocked down by that little one cartridge high gap in the bottom of it. They come through here. It's just been such a massive, crazy project. This is a stiffener material so that this door doesn't turn into a parallelogram, even though it still kind of does. And then here's a fun thing. One of the last kind of interesting things. So you put your glasses on there, and here's a little mechanism, a door latch. This is, weirdly enough, I think one of, if not my favorite part of this entire design. I can't tell you why. There's a sliding track with just a piece of wood cut out, like a little porthole, or like a when ships have different like gateways between compartments, they have like a big grip like that. It's just exactly what it is, and it goes up, it pushes there. There's a spring mechanism here which pulls it back closed, and it just kind of grabs on that hook. So you can close this while it's running, and put it back up and hold it and look inside and see what's up, and then close it again for safety. And these are right here so that you don't forget about them. And that's just about it. There's lots of other interesting little details in this thing, which I could go over for, probably days. But there's your finished parts, all engraved. The slowest part is now the laser, which we were told would be able to hit 4 seconds per cartridge, and that's not really turning out to be entirely accurate. It might be closer if we weren't having to wait for the silly homing rotation, but the quality's beautiful. I'll give them that. It's really small. Please ignore my dry boys. Okay. That's all for now. Thanks for watching.